So now I'm going to walk you through the review we did in class before taking our quiz on random variables. And I already have the key up here, so we'll just talk you through it. So Mrs. Overman tracked the number of students absent to her 5th period stats class and created the table below. She never had more than 3 students absent. All right, so here I have, I had 0 students absent. We don't know what percent of the time they weren't there. 1 student absent, 42%, 2 students absent, 17%, and 3 students absent, 5%. Then I ask you to determine the missing probability in the table. So what has to happen is all 4 of these must add up to 1. So I say, okay, 0.42 plus 0.17 plus 0.05. And let me do an easy Google calculator. What is it? It was 0.42, 0.17, and 0.05. 0.42 plus 0.17 plus 0.05. And you see that's 0.64. And then I just subtract that from 1 minus 0.64. I can go the other way around. Just remember it's not negative. And my answer is 0.36. So that's how I got 0.36 there. Over on the right side, I do the same thing, except now we're going to find out that I have this one missing, but it's the same idea. We add these up, we get 0.8, so that one has to be 0.2. So how do you know this is a valid probability model? It's the same answer for both sides. All the probabilities between 0 and 1 are between 0 and 1. So we don't have any negatives. Remember how I said if you subtract wrong and you get a negative, don't use the negative. And the sum has to add up to 1. So calculate the probability that at least 2 are absent. So what does at least 2 mean? Well, this would be at least 2. So there are a couple of ways to do it. You can say probability, by the way, that's the same as the probability that x is greater than 1. So you can see, make sure you understand, because you will have some questions that will ask you to put the right values in here. So at least 2 is definitely greater than 1, all right? So, oops, there we go. And so we add up the 0.17, 0.05, and we get 0.22. Calculate the probability that at least 2 are tardy. Same thing here. You would add these 2 values. We know that missing value is 0.2. Okay. So in fact, I can just go ahead and put those missing values in. Here's point. It'll make it a little easier to follow along. And this one is 0.2. So we fill in those values on the table. Okay, calculate the probability that at most 2 are tardy. So what does at most 2 look like? At most 2 means it's 3 is more than 2, so that doesn't count. At most 2 is 0, 1, and 2. So that would be all these probabilities added up together. All right, so that's how you get 0.36, 0.42, and 0.17. All right, and at most 2 also on the right side. So that means you would have 0, 1, and 2 count as at most 2, and you can see we just add those up, which we actually did in part 1 already, and we get 0.8. Okay, what is the probability that at least 1 student will be absent on any given day? Oh, and notice that at most 2 is less than 3, because we said at most 2, we did not include the 3, okay? So you are expected to be able to change these words into the symbols. What is the probability that at least 1 student will be absent on any given day? Well, we can just say at least 1. That means that's more than 0, so I would just add those right there, okay? You can see that's what I did, 0.42, 0.17, 0.05, right? And I get 0.64. Or I could just add the probability, take the probability 1 minus, I'm sorry, just 1 minus the probability of having 0 absent. That is the same as at least 1. And I pretty much did the same thing here. At least 1 is this area right here, and add all those up, and that's pretty straightforward. Okay. Then finally, I asked for the expected number of students and the standard deviation. So we hit the stapplet. So I'm just going to go ahead and show it for this first one here. So if you go to stapplet, well, let's go to stapplet, right? and we get discrete random variables is the one we want, and we put our values in here. We had 0, 1, 2, and 3 was the most. And let me just refresh. 0.36, 0.42, 0.17, 0.36, 0.42, and 0.17. And if your value here is wrong, pretend I put 0.17 again, it's going to say, oh, that doesn't work. So I have to make sure I put in probabilities that make it add up to 1, and it'll give me a pretty picture here. So you can see, the sad part is it won't do at most, at least, or anything like that on here like it will with a binomial. But it does give you your summary statistics right there. 0.91 is your mean, and 0.8496 is your standard deviation. And if you have trouble, you're like, oh, I don't have as many decimals, you can always adjust that down here on that blue bar. Again, you just click down here anywhere on this blue section, and you can change how many decimals you have. All right, and you can change from decimal to percent. And I just basically did the same thing. I put in 0.19, 0.49, 0.12. Actually, I could probably do that quick. 0.19. Yes, that's okay. 0.49. And it was 0.12, and I think this was 0.2 at the end. Begin analysis. And you can see there's the mean and the standard deviation for this distribution, 1.33 and just over 1. Boom. And that's it. Good luck on your quiz.